Okay, here we go. So you're supposed to verify that that's the integral. So how do you verify that? How do you verify something is the integral? You take the...
The derivative of the negative x value.
So you want to differentiate this.
Or take the antiderivative.
You could, but if they give you the great... Is it generally easier to differentiate or integrate? What do you think? It's generally much easier to differentiate. So let's do this here. Well, first of all, what's the derivative of a constant? That goes to 0. So what is this right here? This is actually xa squared times a squared minus x squared to the what power? Negative 1/2. And what do you treat a as? A is a constant. Yes. A is a constant. Oh, it's a squared, right? So what rule do you have to use to differentiate this in this form? Product rule. No, product rule. Just product in the chain rule. Yeah, exactly, yeah. So let's do this out. The derivative of the first, you're doing it with respect to x. If x is a constant, what's the derivative of x a squared? It's just a squared. So you get a squared times this plus the first times the derivative of the second. What's the derivative of this going to be? Negative 1/2 times a squared minus x squared to the negative 3/2 times what? Negative 2x. Now you just have to simplify and see what happens.
Wait, how'd you get,
how did I get what?
How did you get the x a squared? How do you move a squared to the top?
Okay, hold on. Let him finish, and then you can talk.
I'm so confused. How'd you get the a squared to the top?
How to get the a squared to the top? Which is the a squared to the top?
Like,
Look, we set it up incorrectly. You're absolutely right. The a squared right there, where should that be?
it should be in the denominator.
It should be in the denominator, right? So you could, if you really wanted to, you could just do this instead. You went a to the negative 2, and you just make these negative 2's right here. Did you see what I mean? Just make, I'm making it negative 2, and a to the negative 2. So that's a negative 2. You see, I'm just making it, you're right, you're absolutely right.
And then the one. I did that.
So now what cancels? A few things cancel, right? The 2 cancels with that, the negative cancels with that. So what are you left with? What does this simplify to? Yeah, so now you have to actually combine the fractions here. So it's 1 over a squared times, yeah, you can go to the radicals. That's totally fine. Root a squared minus x squared plus, what's left on top here? X squared, right? Because there's an x there and an x right there.
Yeah.
Over what? A squared times the... You have to be careful. Let's just make it a squared minus x squared to the what power? To the 3/2 right there. And let's just make this, because we're not quite done yet, let's make this to the what power? To the 1/2. Is everybody okay with that right there? Okay, so at this point, how do you combine fractions? You need a common denominator. Do you agree with that, everybody? Yeah, you're going to have to multiply this by what?
A squared minus x squared?
Yeah, a squared minus x squared to the what power? To the first over a squared minus x squared to the first. Why is it to the first power?
Because that makes a squared minus x squared
to the 3/2. Exactly, Biggie. Very good. So what do you end up with? You end up with a squared minus x squared plus x squared all over what? A squared times a squared minus x squared to the what power? 3/2. What cancels? Those cancel because you're adding and subtracting the same thing. And then what cancels because of division? That cancels. So what are you left with? 1 over the cube, 1 over the square root of a squared minus x squared all to the 3rd. And is that exactly what we have up here? Yes, it is the same thing. Absolutely. So in this case, it was doing the derivative to verify. We use that trig identity, and we end up with the integral of 2 sine x cosine x all over dx. What cancels? Yeah, now is it a heck of a lot easier? Yeah, you can pull that 2 out, right? 2 cosine dx. Is this a definite or an indefinite integral? Indefinite, so it's going to be 2 sine x. You could say plus c, that's fine. You could say plus c. At this point, I wouldn't take a point off for this one, but if it asks you for the general antiderivative, you'd have to do the plus c.
Okay.
Much to keep track of. There's much to keep track of. There's much to keep track of. So if you try it out, what happened when you tried some of your guesses? It's really hard to cancel everything out. Do you agree? It's really hard to cancel everything out? Okay, so we're going to talk about something called, you're going to do this many times, u-substitution. This is not very hard. Take a look. I'm going to pick something for my u, and it's called u-substitution because u is the most common letter used. Fine, you're going to want to watch this. I'm going to do number 2 here. I'm going to say u is equal to 1 minus 4x squared. If I took the derivative of both sides, of this equation, what would I get? Take a guess. We now have du is equal to negative 8x dx. So what does dx equal? Negative 8x over what? Du. We're just isolating it right now. Do you see that? I divided both. Oh, excuse me. Ha 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 ha. I can almost do basic algebra. Du over negative 8x. Okay, so why does that help me? Well, let's take a look at our original equation right here. So what are we looking at? We have the integral of what? X over what? The square root of 1 minus 4x dx. But what does dx equal? So what do you end up with? X over the square root of u times du over what? Negative 8x. What cancels here? The x cancels. What can I pull out to the front of this integral? Negative 1/8. And it's the square root of, or 1 over the square root of u du. How can you rewrite that? Negative 1/8 times the integral of u to the what? Negative 1/2 du. Can you integrate that for me? Yeah, integrate it for me. It's going to be negative 1/2 times what? So negative 1/8 times what? It's going to be u to the what power? 1/2. So what do you have to put up front? You said it. 2. The du goes away. So what does this simplify to? Negative 1/4 u to the what? U to the 1/2. But what did u equal? No, it's just 1 minus 4x squared. Right?
Yeah.
That's what u equaled. So where do we plug that back in? You plug it in right here. So what do you end up with? Negative 1/4 times 1 minus 4x squared to the 1/2. So this right here is our antiderivative. What we essentially did was we found a way to keep track of everything we needed to do by making a proper first pick. Your question might be some of the specifics of like the exact notation right here, but your bigger question really should be, where did this come from, right? Like, why did I pick that? You will get really good at picking u-substitutions. Is u-substitution always going to work on every equation? No. At the beginning, they're going to do what they did in many other things you've done in math, which is first, stop twitching with the little pieces of metal, and second, they're going to say, solve this using u-substitution, solve this using u-substitution, and then eventually, are you going to be able to recognize when you can use u-substitution? Yes. How would we check to see if this is the proper answer? Take the derivative. What do you end up with? Negative 1/4 times 1/2, 1 minus to the what? Negative 1/2 times what? Negative 8x. What cancels here? The negatives cancel. The 4 and the 2 and the 8 cancel. And what are you left with? X over the square root of. Did it work? It worked. This one together. The first thing you do is you differentiate the u expression. So what is du going to equal? 3 squared dx. So what does dx equal? Du over what? 3x squared. Now you substitute. So you get x squared times the square root of what? Of u. But instead of dx, what do you write? Du over 3x squared. What cancels at this point? This right here, that canceling, that action right there will make you feel really, really good. Because if you can cancel out and end up with something you can integrate, you're home free. The entirety of what we just did was there so that we could cancel out. So now what do we have? The integral of u to the, but what goes on the outside? So what does that integrate to? 1/3 times what? 2/3 u to the 3/2. But what does u equal? So you have 1/3 times 2/3 is going to be 2/6. 1/3 times, what does u equal? x cubed plus 1 to the what power? 3/2 plus c. There is your general antiderivative. There it is right there. They're going to start you off. Oh, did I do something wrong? The 2/3. Oh, I didn't do it. 2/3 times this is 2/9. 2/9. Not 1/3. What are we doing here? Our basic algebra needs a little work. 2/9. Absolutely. There it is. Pretty cool. Sometimes you can do it out without doing all of these steps, but I will tell you, you will make mistakes. You will make mistakes. You will forget about some aspect of the chain rule. You'll forget about some aspect. What does du equal on number 5? Du is equal to 2 dx, right? So what does dx equal? Du over 2. So now what do we have? The integral of 4 over u to the times what? Over 2. So what does that simplify to? 2 times the integral of u to the what power? Du. Nice. So you end up with 2 times, what do you have to put out front? Negative 1/2 u to the negative 2. So what does that turn into? 2. So that turns into negative, negative, what was u equal to? 1 plus 2x?
Yeah.
1 plus 2x to the what power? Negative 2. There it is right there. Very nice. Let's actually do the second one as well. E to the u times what? D theta is du over, times cosine theta times, basically what you're doing is taking care of this. You don't need to track the, with the chain rule anymore, excuse me. So you have e to the u du. What's the integral of that? E to the u. So in this case, the answer is going to be e to the sine theta, which should make sense because the derivative of e to the sine theta is e to the sine theta times the derivative of sine, which is cosine. So when these work, do they work really nicely?